Hi there, math students. Dr. John, your physics and math professor, to work on another trig identity with you. Here we have a really odd looking thing. It's cosecant squared plus secant squared equals cosecant squared times secant squared. It would seem unusual that that would occur. We're going to try to prove to see if it's right. I don't know which side is going to be the easier to work with. Let's start by working here on the left-hand side. We've got something in secants and cosecants. We don't like that very much. Let's return these to the things we know and love. So this would be sine squared theta plus 1 over cos squared theta. Immediately we're looking at this and we're saying this looks like something that could be Pythagoras' theorem. Sine squared plus cos squared equals to 1. We're going to use these different principles, the difference of squares, Pythagoras' theorem, double angle, and trig definitions to do these various trig identities. So here we've got something that looks like it, but it's not right, obviously. Those things need to be positive in the numerator, not in some weird way in the denominator. Let's try multiplying both the top and the bottom of each of these by a factor so that it might turn this into Pythagoras' theorem. I've changed colors to do it here. So I've multiplied cosine squared here on the top and bottom. This sine is still here. Plus, doing the same thing here only with sine squared theta over sine squared theta. This is the same thing, cos squared theta. So I've left this cos and this sine here. I've just multiplied each of them by the other factor, by the other trig function, in hopes of creating something like a Pythagoras' theorem. Well, now we've got a common denominator here. We write this over here. We've got sine squared theta, cos squared theta. Each of these here in the denominator. And what's our numerator? Cos squared theta plus sine squared theta. This is Pythagoras' theorem. So this is 1 here on the top. Now created something that looks interesting. Now we've got this and we've got this over here. Let me do some erasing. I've got this here on the left side here. So this is 1. I'm going to split these up. 1 over sine squared theta times 1 over cos squared theta. I've just taken these, split them up into two things. This is the same as this. 1 times 1 is this times this is this. Now each of these can be flipped. This is the same as cosecant squared theta, and this is the same as secant squared theta. These are the reciprocals of this. Notice we now have the same thing as we have over there. So we've proved that identity. Hope that helps. If it does, like and subscribe, and we'll see you on the next one. Bye-bye.